Hello all you math lovers out there, this is Nitesh, and in the next few minutes we'll be talking about solid figures. Now, we all know what a solid is. A solid is a three-dimensional figure that encloses a part of space, right? Now, we won't talk about the basic definition. We'll be talking about the classification of solids. So, let me try the classification of solids. Now, how can we classify solids? We can classify solids as prism. Okay, now this is cylinders. We can classify it as pyramids, and we can one more can be cones, and we can classify it as a sphere. All right, now this is the classification: prism, cylinders, pyramids, cones, and spheres. Now prism can also be classified as into two types, that is rectangular prism and triangular prism. Now this is the basic classification of prism. So let's take prism. Okay, now we'll talk about the prism. Let's talk about the surface area of a prism. Okay, now what is the surface area actually? Now the surface area of a prism, we can denote it as S, and the surface area of a prism is the sum of areas of its faces. But before that, we have to show that what actually the faces are. Okay, so some solids are formed by polygons, right? So that polygons are called the faces. Now the segment where the faces meet called the edges. Okay, and each point where the edges meet is called a vertex. Let me show you this with an example. All right, let's draw this diagram over here. This is a solid figure, so let's just draw this diagram. These are the imaginary lines or the hidden lines. Okay, now we talk about the faces. Now this whole is a face. Okay, this is a polygon, a rectangle, a square, anything, so that is called a face. Now this one side is called an edge. Okay, so the segment where the faces meet are called the edges, and so this is the edge. Now each point where the edges meet, so this is the point where the edges are meeting, and this is the point where the edges are meeting. Here, this is the point. So these points are called vertices, or singularly we can call it as vertex. So these are the three words which are very important in solid geometry: face, edges, and vertices. Alright, so we were talking about the surface area of prism. So let's just go back to surface area of prism. As I told you, surface area of a prism is the sum of the areas of its faces. Now let's take an example. Suppose if we have a rectangular prism, something like this. Okay, something like this, and this is a rectangular prism, and these are of course the hidden lines. Okay, so don't worry about the diagram. We are actually concerned about the dimensions. All right, so this is 3 centimeters, and this is 2 centimeters, and this is 4 centimeters. All right, so 3, 2, and 4 centimeters, these are the dimensions of our rectangular prism. All right, now we got to find the surface area of this prism. So we find the surface area, or the area of the top face. Okay, even if we talk about the top or the bottom, both are the same, so both the areas will be same. So we first find the area of the top or the bottom face. All right, top or bottom face. So the area will be 4 times 2. Okay, because this is 4 centimeters and this is 2 centimeters. and this one is the top side. So that's why we are considering these two dimensions, 4 and 2, because this is 2. Alright, now 4 times 2, we already know how to find the area. So 4 times 2 will be 8 centimeters squared, or squared centimeters. Alright, now we find the area of the front or the back face. Front or the back face, both will have the same areas, so that will be 4 times 3. Now front and the back face, now we have to consider 4 centimeters and 3 centimeters. So that will give us 4 times 3, that will be 12 centimeters square. Alright, now the last one will be either we find the left or the right. Alright, so left or the right face, so the area of the left or the right face will be 3 and the 2. Okay, we are talking about this face and this face. That will be 3 times 2, and that will give us 6 centimeters square. So we got all these three areas, the top or the bottom, front or back, and left and right. Okay, so now we add up all the things. Alright, so put it up together, add up, so we'll get 8 plus 8, because there are two faces, top or bottom. Then we add 12 plus 12 for the two, front or back. Now we add 6 plus 6 for the left and the right. Okay, so now we have 1 2 3 4 5 6 6 faces, 6 areas. We add up all these things and we'll get in the end 52. So this 52 square centimeters will be the surface area of this prism. Alright, so this was all about the surface area of a prism, and this was the very basic example of surface area of the prism. Alright, so now we talk about the volume of the prism. Now, as the surface area, volume of the figures is also very simple. Now, volume of a rectangular prism, we have a very simple formula, V, that stands for volume, and length, L is for length, times width times h, that is the height. Okay, so we know what the length is, we know what the width is, we know what the height is. So when we multiply all these three things, we'll get the volume of rectangular prism, and this is the very simple formula. So let's take an example. Suppose if we have the dimensions 8 inches and is the length, of course. Now width is 6.2 inches, alright, and height is 3.9 inches. Alright, so this is the height. Now these are the dimensions we are given. Now how will you find the volume? Just put these in the formulas. 8, that is the length, 6.2, that is the width, and 3.9, the height is given. Alright, so we just multiply all these things, and when we multiply, we will get 193.44, and that will be inches cube. Okay, so this will be the volume of this particular prism, and this is how we find the volume of a rectangular prism, by using simple formula L times W times H. That's it for today, and we are doing math. Okay, so people who say it can be done, so shouldn't interrupt those who are doing it. So we're doing it, and please don't get interrupted by the people who say you cannot do it. All right, so that's it for today.